On the night of July 31st, 2026, at exactly 7:46 p.m., the ground beneath one of the most dangerous stretches of coastline on Earth let go. For 11 seconds, the city of Pozzuoli shook. Cliffs crumbled into the sea, century-old buildings cracked down their facades, train lines shut down. A port that ferries tens of thousands of tourists to the islands of Ischia and Procida every summer went silent. And by morning, at least 21 people were injured, dozens of families were sleeping in their cars, and Italy's Civil Protection Department had opened emergency shelters across a region of nearly 3 million people. The quake measured magnitude 4. 7. On paper, that's a moderate earthquake, the kind that barely makes international news in California or Japan. But this wasn't California. This was Campi Flegrei, the Phlegreian Fields, a sunken 12-kilometer-wide volcanic caldera sitting quietly beneath the western suburbs of Naples. And this was the strongest earthquake this specific volcanic system has produced in over 40 years. It didn't come alone. Dozens of aftershocks rattled the region through the night, several topping magnitude 3. 0. Within days, seismologists confirmed what residents already suspected in their bones. This wasn't an isolated event. It was the latest, sharpest spike in a slow-motion crisis that has been building under Naples for more than 2 decades. So today we're asking the question that half of southern Italy is quietly asking themselves right now. Is Campi Flegrei waking up? And if it does, what happens to the people living on top of it? The ground that breathes. To understand why a magnitude 4. 7 earthquake has scientists across Europe on high alert, you first need to understand what Campi Flegrei actually is. Because it is not a volcano in the way most people picture one. There's no towering cone, no snow-capped peak, no single crater you could point a camera at. If you flew over the area today, you'd see suburbs, marinas, ancient Roman ruins, vineyards, and the busy port town of Pozzuoli, all sitting inside something far larger and far more dangerous than any single mountain, a caldera. A caldera forms when a volcano doesn't just erupt, it collapses. Roughly 39,000 years ago, an eruption so violent it's classified among the largest in Europe in the last 200,000 years, emptied a massive underground chamber of magma. With nothing left to hold it up, the ground above caved in, leaving behind a vast depression nearly 12 by 15 kilometers wide. A second, smaller collapse followed around 15,000 years ago. Half of that ancient scar is now submerged beneath the Gulf of Pozzuoli. The other half is where hundreds of thousands of people now live their daily lives, often without a second thought about what's underneath their kitchen floor. Since then, Campi Flegrei has erupted dozens of times. At least 24 separate craters and volcanic vents are scattered across the caldera, evidence of a system that has never fully gone quiet. The most recent eruption happened in 1538 when, over the course of just a few days, a new hill rose out of nothing near Pozzuoli. Locals named it Monte Nuovo, New Mountain, and it stands there today, a green, grass-covered reminder that this ground is capable of building itself a new landmark in less than a week. But Campi Flegrei's real signature isn't sudden eruption. It's something rarer and, in its own way stranger, bradyseism. The word comes from Greek, brades, meaning slow, and seismos, meaning movement. It describes the ground here rising and falling over months, years, even decades, as magma and superheated fluids shift beneath the surface, swelling the crust like a balloon being slowly inflated and deflated. You can see the evidence of this process written into the ruins of the ancient Roman marketplace at Pozzuoli, misleadingly nicknamed the Temple of Serapis. While its marble columns are pockmarked several meters up their length, bored out by marine mollusks. That means those columns were once underwater, submerged as the ground sank, and later lifted back into the open air as the ground rose again. It's a 2,000-year-old sea level gauge, carved by nature into stone, and it's the reason volcanologists have known about Campi Flegrei's breathing pattern since long before modern seismometers existed. The modern crisis, 20 years of rising ground. Bradyseismic episodes aren't new. The area went through major uplift crises in 1969 to 1972, and again from 1982 to 1984. The latter forcing the evacuation of roughly 40,000 residents from the historic center of Pozzuoli as the ground rose nearly 2 meters in just a few years. Both times, the unrest eventually stalled and reversed. No eruption followed. What's happening now is different, not necessarily in kind, but in duration and persistence. The current uplift phase began around 2005. At first, it was barely noticeable, a few millimeters a year, but it hasn't stopped. Instead, it has steadily accelerated. As of the most recent INGV, Istituto Nazionale di Geofisica e Vulcanologia measurements, the ground near Pozzuoli has risen by more than 140 centimeters, over 4.5 feet, since the crisis began. Right now, it continues to climb at a rate of roughly 10 millimeters a month, sometimes higher. And where the ground rises, the rock breaks. As the crust stretches and bends to accommodate the swelling below, it fractures. And every fracture is an earthquake. That's why the seismic record at Campi Flegrei tells such an unnerving story. In the early 2000s, tremors here were rare and barely felt. By early 2023, INGV had logged more than 9,000 seismic events in a single year. Weekly earthquake counts that once sat near zero were, by early 2026, regularly running between 40 and 70 events a week, even during so-called quiet stretches. Then came 2025 and 2026, when the ceiling kept getting knocked higher. In June 2025, a magnitude 4. 6 earthquakes struck, at the time the strongest recorded at Campi Flegrei in over 40 years, and one that caused visible structural damage across Pozzuoli. Scientists and residents alike hoped it might mark a peak. It didn't. Just over a year later, on July 31st, 2026, that record fell again, this time to magnitude 4. 7, accompanied by a swarm of more than 30 tremors in a single evening, several of them exceeding magnitude 3. 0. In the days since, the region has continued to shake, with a magnitude 4. 5 events striking just west of Naples on August 1st, and steady background seismicity continuing into the days after that. That's the pattern seismologists find most concerning. Not a single big shock, but a rising staircase. Each new strongest earthquake in decades, replaced by an even stronger one within a matter of months. What the scientists are actually seeing. So what's driving it? According to INGV's analysis, the July 31st earthquake likely occurred along what's known as a ring fault, a curved fracture that traces the buried edge of the ancient caldera collapse, deep in the crust. Ring faults like this tend to host the larger earthquakes in this system, because they can rupture over longer, more continuous stretches of rock than the smaller, shallower faults that produce most of Campi Flegrei's everyday tremors. Alongside the shaking, scientists are tracking a second equally important signal: gas. At the Solfatara crater and the nearby Pisciarelli fumarole field, both popular, if slightly surreal, tourist stops where the ground visibly steams and bubbles, researchers have recorded rising temperatures and elevated emissions of sulfur dioxide and carbon dioxide. Geochemical monitoring shows a long-term trend of the underlying hydrothermal system heating up, which researchers interpret as a sign that pressurized fluids and gases from deeper in the system are pushing closer to the surface. Put together, accelerating uplift, an escalating earthquake pattern, and a heating hydrothermal system. This is why, back in 2012, Italian authorities raised the official alert level for Campi Flegrei from green to yellow, meaning attention. As of today, that yellow alert remains in place. It sits 1 level below orange, pre-alarm, and 2 below red, alarm, under which evacuation would begin. Crucially, and this is the point every serious volcanologist studying this system wants the public to hear clearly, a yellow alert does not mean an eruption is imminent. It means the volcano is being watched more closely than almost any other on the planet, with instruments tracking its every twitch, because the range of possible outcomes is wide enough that nobody can afford to look away. Researchers modeling the system, including recent work combining stress-based fault models with statistical earthquake interaction analysis, have found that the current unrest fits patterns consistent with what's sometimes called an accelerating phase. Not necessarily a phase that guarantees eruption, but one where the probability of larger events, and the pressure on the system generally, continues to build rather than plateau. Some published projections have even floated a possible critical transition point as early as the early 2030s, if current trends continue uninterrupted. Though scientists are careful to stress that bradyseismic crises have stalled and reversed before, twice in the last 60 years alone, and could do so again. In other words, nobody, not INGV, not the world's leading caldera specialists, can currently tell you with certainty whether Campi Flegrei is heading toward an eruption, a return to quiet, or years more of exactly this kind of grinding, unsettling unrest, the human stakes. Here's what makes Campi Flegrei genuinely unique among the world's monitored volcanoes: the sheer number of people living directly on top of it. Estimates vary depending on exactly how the boundary is drawn, but roughly 500,000 people live within the official high-risk red zone spread across 15 municipalities, including much of Pozzuoli, Boccoli, and parts of western Naples. Zoom out to the broader Campi Flegrei and greater Naples metropolitan area, and you're looking at a population approaching 3 million, one of the most densely populated volcanic risk zones on Earth, and arguably the most dangerous, given how close it sits to a caldera capable, in its most extreme historical episodes, of continent-altering eruptions. That combination, enormous population density plus genuine volcanic uncertainty, is exactly why the July 31st earthquake made global headlines rather than staying a local Italian news story. When the quake hit, Authorities in Pozzuoli evacuated around 250 people from the area immediately around the worst damaged buildings. As structural inspectors fanned out across the city in the days that followed, that number climbed. At least 9 buildings were declared officially unsafe, and roughly 290 residents were formally barred from returning to their homes, with checks still ongoing. Rail lines connecting the Campi Flegrei towns to central Naples, the Cumana and Circumflegrei lines, used daily by commuters and tourists alike, were suspended for safety inspections. The port of Pozzuoli, a key gateway to Ischia and Procida during peak summer tourist season, closed its gates entirely for a period, stranding ferry passengers and disrupting one of the region's biggest tourism corridors at the worst possible time of year. None of that is what a supervolcanic eruption looks like. It's what a strong, shallow, moderate earthquake looks like in a densely built historic Italian coastal city with aging infrastructure. But it's also a preview, a stress test, of exactly the kind of disruption authorities are trying to plan for on a much larger scale, because Italy's Civil Protection Department has, for years now, maintained a standing evacuation plan for the entire red zone, roughly 500,000 people, a logistical operation on a scale most countries have never had to seriously rehearse for a single hazard. Could it actually erupt? This is the question that brought most of you here, so let's address it directly, without the hedging, and also without the hype. Could Campi Flegrei erupt? Yes. It is an active volcanic system. It has erupted numerous times in the past 15,000 years, and the current unrest shows genuine, measurable signs of magmatic and hydrothermal pressure building beneath the surface. Nobody credible is telling you this system is dormant or dead. Is an eruption imminent, meaning days, weeks, or even the next few months? Based on everything INGV and independent researchers are currently seeing, no. The alert level remains yellow, not orange or red, specifically because the monitoring data, while concerning, has not crossed the thresholds that would indicate magma is actively approaching the surface in the near term. Ground deformation, while significant in total, is proceeding at a rate measured in millimeters per month, not the rapid, accelerating spikes that typically precede an actual eruption. Seismicity, while intense, remains dominated by small, shallow events rather than the kind of deep, long-period tremor patterns associated with magma physically forcing its way upward. If Campi Flegrei were to erupt, what would that even look like? Here's the genuinely reassuring part. As strange as that sounds to say about a system this size, the vast majority of Campi Flegrei's eruptions, including the most recent one in 1538, have been small to moderate by the caldera's own historical standards. Localized events producing new vents, ash, and localized lava or pyroclastic activity in the immediate area, not repeats of the catastrophic climate-altering supereruption from 39,000 years ago. That ancient event was almost certainly a once in tens of thousands of years occurrence. The much more statistically likely scenario, should this unrest eventually culminate in an eruption at all, is something closer to a 1538 style event. Serious, locally devastating, requiring evacuation of nearby zones, but not an extinction-level catastrophe for Europe. That said, smaller is relative when the surrounding area holds 500,000 residents, an international airport, a major port city, and some of Italy's most valuable ancient heritage sites. Even a modest eruption in the wrong location could be genuinely catastrophic on a local and regional scale, which is precisely why Italian authorities take this system as seriously as they do, and why that evacuation plan for the red zone isn't a theoretical exercise sitting in a drawer somewhere. It's actively maintained, tested, and updated as the unrest evolves. What happens next? So where does this leave Naples and the millions of people who call this region home? For now, life continues. Trains are running again. The port has reopened. Tourists are still climbing down into the sulfurous, steaming crater at Solfatara for a first-hand look at the very system making global headlines. That's not recklessness. It's a reflection of just how long this community has lived alongside genuine, low-grade volcanic uncertainty, and how thoroughly Italian scientific agencies have integrated monitoring into daily life here. Seismometers, GPS stations, gas sensors, and satellite radar are tracking this caldera in near real time, feeding data to INGV around the clock. If the situation meaningfully escalates, if uplift rates spike, if deep, long-period earthquakes begin appearing, if gas emissions surge, the alert level will change, and Italy's evacuation apparatus, built and rehearsed over decades specifically for this scenario, will activate. What we can say with confidence is this. The trend line at Campi Flegrei over the past 2 decades has been one of gradual, sometimes punctuated acceleration. More earthquakes, bigger earthquakes, more ground movement, hotter gases. The July 31st quake fits that trend. It doesn't necessarily redefine it. Whether that trend continues climbing toward an eventual eruption, or whether, like in 1972 and 1984, it eventually stalls and the ground begins to settle back down, is something that even the scientists staring at this data every single day genuinely cannot yet tell you. What they can tell you is that they'll see it coming before almost anyone else on the planet would, in almost any comparable volcanic system, because nowhere else on Earth is quite this closely watched by quite this many instruments for quite this long a stretch of sustained unrest. For the people of Pozzuoli, Bacoli, and the western edges of Naples, that's not nothing. It's not a guarantee. But after living for 21 years atop ground that quite literally rises and falls beneath their feet, it may be the only kind of certainty this particular corner of the planet has ever really offered. We'll be watching Campi Flegrei closely in the weeks ahead, and if the data shifts, we'll be back with an update. If you want to understand more about how supervolcanoes and calderas actually work, and why most of them behave nothing like the disaster movies, check out the video on screen now. And if this kind of deep dive Earth science content is what you're here for, make sure you're subscribed, because this story is far from over.